out of order on the back because I want to save the hardest formula for last, the one that's going to require the most work. So let's look at the circles and the ellipse. So we just reviewed that our circle formula was pi r squared. And we learned that our ellipse formula wasn't much different. It was pi, but instead of r squared, it was r times the other r. And they're two different numbers. The only thing that can make this one at all hard is make sure that you're using the radius. Did they give us the radius here? No. What's the radius on this circle?
5.
This one. 4.
8.
8 is the diameter, so the radius has half of that. So when I do r squared, that's r times r, so what's r squared? So you just put 16 pi, and this is in feet squared. Circles are one of the easiest ones. On this one, it would be just as easy because they gave you the radius. What's 5 squared?
25.
So you put 25 pi, and then this one was yard squared. So they go really easy when it's circles. Okay. For the ellipse, it's almost as easy, but the only difference is you have to use two different radiuses. This one here, they didn't give it to us, but if you look, it's on a coordinate plane. I started down here at -2 and I went up to 1. How far apart is that?
1.
To go from -2 to +1.
3.
It's 3. So one of our radiuses is 3. To go from here to here, I went from 1 to 6. How far over is that from 1 to 6?
5.
So when I plug that in, 3 times 5 is what? Yeah, 15. So I put 15 pi. And there's no units on this, so it's just units squared. So do y'all see how the ellipse is the same amount of work? It's not any harder than the, the circle. It's just, instead of multiplying the same number twice or squaring it, you're just doing two different numbers. But it's still just something times something with a pi next to it. So these are the easiest ones. Now, our very last one, the formula we have not done yet. We've done every formula on this formula chart except for this one. It's a simple formula, half PA or half AP. Just two things. But getting the A or getting the P can be challenging. Okay? And what I mean by that is they're only going to give you one piece of information most of the time. They'll either give you a side length, or they'll give you the apothem, or they'll even give you a radius. Okay? Which is the most amount of work if they give you the radius. So it doesn't really matter which one we do. I'm going to start with the one that didn't draw a picture, just because. Now, the method that we're going to have to do, you can do on every single regular polygon. The only difference is every polygon has a different amount of angle. So you have to use that chart where we wrote down what the angles were on them. Not chart, like those notes, so that you had the pictures and you wrote down what the inside angles were on every one of them. You're going to want to use that. Otherwise, you're going to have to use the formula that we talked about that day to find it yourself. They're not going to give it to you. Now, that being said, 3 of our polygons have a shortcut. If you have a triangle and you're dealing with the apothem instead of like base and height, you will end up taking a shortcut doing a 30, 60, 90. If you have a square, although it's much easier just to do side squared, you would have a 45, 45, 90. And if you're doing a hexagon, you're also going to have a 30, 60, 90, but your 30 and your 60 are going to be in different places than the triangle. Every other polygon, you have to do trig. You have to. There's no option. There's no way to do these problems without bringing in trig. So y'all remember SOHCAHTOA? The sine, cosine, and tangent? Well, that's not quite right, but yes. Alright. So, guys, we're going to do the pentagon one, but remember, this process works for all of them. And pretend my sides are closer to being equal. They're not in this picture. But a pentagon has 5 sides, right? So if every side is 24, we know that they're all the same. They're all 24. if I draw my apothegm, okay, the 24 is getting split. So what's this piece right here? 12. There's a right angle here, whether or not they draw it for you, because the apothegm always makes a right angle. And then this right here is called the radius, okay? Just like with a circle, because if you put this inside a circle, that's where it would touch. You're going to focus. In this case, for a formula being 1/2 AP, we can easily find P, right? Because if I have one side and they're all the same, 5 times 24 will get me the perimeter. But I need to find the apothegm, okay? So when you're looking at your notes about the angles, every one of these angles in a pentagon was the same thing if it's regular, and they're all 108. Okay, that's all of these. But this one right here is split in half. Notice it's not the whole 108, the other part's over here. So it is actually in half. I know my picture doesn't look like it, but that's because it's taller and skinnier than it's supposed to be. It just did a sketch. But if I half this number, I get 54. That's what goes right here. 54. Okay? Zoom in a little bit so y'all can see better. You have to remember your trig. Right next to the 54, the 12, this is our adjacent. The one we're looking for, our apothegm over here, this is opposite. Do y'all remember which trig function you use for opposite and adjacent?
10.
Yes. And you're almost always going to use tangent. Every now and then, if they give you the radius, you can use sine or cosine, but you're going to use tangent most of the time. So we're going to do tangent of 54 equals, and it's opposite, which is the apothegm that we're looking for, over adjacent, which is 12. Okay? This is how we're going to find the apothegm right here. So since the A is on top, I can multiply by the bottom number, the 12, to get A by itself. This right here is A. We already said that P was 24 times 5. We already knew that P was 24 times 5 because 5 sides, they're each 24. Sorry. I'll zoom out a little bit. We already knew that the perimeter was 24 sides, 5 of them for the whole thing. So when we plug this all in here, you can find these two numbers first, but I tend to just put it all in one. I've got 1/2, then my perimeter is 24 times 5, and then my apothegm is 12 times the tangent of 54. The only thing you got to remember is don't put tangent of 54 separate. That 54 doesn't go with these numbers. That's part of this. What's half of 24?
12.
What's 12 times 5?
60.
And then 60 times 12? Don't put it in your calculator. We're at 60 times 12. Yeah, 720. So this is what we would put in our calculator. Now, those of you that insist upon using your phones instead of grabbing a calculator up here, if you have an Android, type it in just like that. But if you have an iPhone, you got to go backwards. All right, so I have an Android, so just make sure it says degree mode on your screen. So 720 tangent 54. And we're just going to round for this nearest whole number, so 991. So 991 units squared. Now, if you have an iPhone, remember what you have to do is first you type in 54, then 10, and then after you get that answer, you do times 720. You have to go backwards if you have an iPhone. But you should still get 991. So somebody with an iPhone typing it in? $54, then 10, then whatever you get times 720. Did you get 991? Yeah. It's just a little more difficult typing it in with an iPhone. That's why I tell you we have calculators up here. So if you don't want to have to try to remember to do it backwards, it's easier to type it in. So we didn't do every single problem, but whether it's a pentagon or not, The rest of them are done the same. The only difference is here where we had the 108, every shape gives you a different angle, and you have to use your notes to figure that out. And then sometimes you might not use tangent. Sometimes you might use sine or cosine. But you're going to have to do your trig here. Okay? Now, we've done one of each kind for now. We're going to stop there. When we come back after our spring break 2.0, if we want to do a couple more from this to just refresh our memory, and then y'all have your assignment where y'all do it instead of me doing it with y'all. Okay?